So I will end up over here a little bit. I'm wondering if it's better for you guys to come around at that point or for me to turn the engine. So maybe we talk about that when we get there. Okay, all right.
Okay, guys.
Hey, I'm Stefan Papadakis. We're here at the 2019 Sema show, and we're building a Supra 2020 Supra engine live here at the show. This is the same engine we've been building on our YouTube series. Yesterday we did the crank, rods, and pistons, the rotating assembly. And then today we're going to work on the timing components, the cylinder head, and hopefully we can get to the Valvetrain all within the 2 hours. Let's get started. So I've already laid out a lot of the parts that we're going to try to get to today. We're going to start actually on the bottom side now. And some of the stuff I actually did not get you to yesterday, which was the oil pump. So as I flip the engine over, you can see we've got the crank rods and pistons in, and we've got this the girdle all bolted in, which ties in all the main caps with the skirt. And now we're going to put the oil pump, which goes on this side, and it's a chain drive, and it's this big contraption right here. So the way this works is it pulls in oil from the oil pan through this screen. It then pumps through here and then out through all of the different systems. So what drives it is this chain, and this chain, drives off of one of these two gears on the crankshaft. So that will line up just like that. So we'll come back and do that after I get the pump bolted in. The pump is bolted in with these 4 bolts. So this has been a fun live production here. We've actually had this engine assembled once. So this is the same engine we've been doing on the whole series. And we tore it down, changed the parts like that we wanted to change, pistons, rods, head studs, things like that. And then reassembled it. We ran it on the dyno a couple of days last week, and we had some good success. Tore it all down, cleaned all the parts, and now we're reassembling it here at the show. So I'm going to go into the toolbox and look for this eTorx socket, which I believe is this one. Nope. The eTorx stuff is a little bit new to me, so I'm still learning all of, when it feels like metric stuff or even standard, I can look at the hex bolt and then I'm like, oh, that's a 14 mil or a 9/16 or whatever. This one I'm still learning a little bit. So what I usually do is just sort of spin them in to save some time and then come back and torque it. And then I've got a whole list of torque numbers here. The oil pump is 15. So we're going to use this torque wrench. So I'll just torque them all up to torque them up to 15. Okay. So oil pump's installed, and now we're going to do the gear that drives it. So the high-end engines have sort of trended towards the oil pumps that are chain driven. And that gives them an ability to underdrive them a little bit. Because if you have a high RPM engine, let's say it's 7,000 or 8,000 RPM, that's a lot of RPM for a pump. So they usually try to spin them a little bit slower than the crankshaft. It's the oil pump bolt, which is actually a left-hand thread. Again, a torque socket. And then the torque for that one, oil, pump gear, 3.6 pounds in the 90 degrees. So I'll bring out my trusty angle torque wrench, which needs to be, so like these things reset, because it does angle at all these different angles. Like whatever angle you hold it at, it can still read the angle. So somehow it needs to know where it is in space. Okay, so what is it? 3. So I'm gonna do the 3 with this one. Right. And then 90 degrees. So I need to not let this turn. So who here's, you look like, you want to help me out for a second? Tool might be a little bit. Okay, so hold on. So I'm going to go that way to actually hold it. Yep, so just hold it there. Keep it pushed in, because the way this works is it's got the 4 holes. So I'm going to turn this 90 degrees. Ready?
Yep.
And this ratchet, this torque wrench lets you. Done. Okay, thank you.
There we go.
So, oil pump's on. Done. Next step, we are going to put on the oil pan. So in order to do the oil pan, we need a little bit of silicone. I'm going to swap some parts here. So this is the pan we're going to install. And I'll leave the head gasket in here. Hide that for a little bit. So inside the oil pan, this is the oil level sensor and temperature sensor. And then a nice aluminum oil pan. So as always, since this doesn't use a gasket, it just uses silicone, I always like to make everything super clean, so you know the silicone has a good, clean piece of metal to adhere to. So I usually kind of one wipe to just get away the oil, and then I'll do another one with a clean part of the rag to just make sure it's super clean. And then same thing to the oil pan. They are, yeah. So shop towels are good around like on the car and stuff, but I really like these lint-free ones. And yeah, it's probably on Amazon. I forgot what they're called though. But I've been using these for years. The pink and the green is a little tacky, but somehow it's become, I don't know, I guess maybe it's my trademark now.
Are you spraying that with brake clean?
Yeah, oh, this is just contact cleaner. But you can use brake cleaner, contact cleaner. Like if I'm in my engine room and I don't want the smell of all that, I just use rubbing alcohol. And then the smell goes away. So if you're working in your garage at night with the heater on or something like air conditioner, then alcohol works well to not get you too fumed out. All right, we're gonna do the timing cover first. I've only, like I said, I've only done this once. But the next thing we're going to do is the timing cutter. So the oil pan, it bolts to the whole skirt here of the block and then also part of the timing cover. So we're going to put the timing chain on and the guides and then the timing cover, and then that gives us the whole surface for the whole oil pan to bolt to. So again, I'll spin it over this way. Maybe I'll leave it a little bit up so it's easier to see. We'll grab the timing chain. So this is what connects the crankshaft to both of the cam gears. And we can actually let that hang for a minute on its gear. And these are the timing guides. So this timing guide is the static one, I think I remember. And this is the one that the tensioner pushes on to adjust it. And then the timing chain rides within it. Let me something like that. And that one goes through the head. Right, okay. So again, this one gets siliconed on. And then also there's bolts that go through the middle of it, so the silicone actually has to go on these center ones as well, where the bolt holes go. All right, move this for next. Okay. And the silicone I'm going to use is just, it's a new tube of it. I like this ultra grade stuff. There's a lot of factory stuff that's quite good too, but this one seems to seal up well. It's the same color as the aluminum, so you don't end up with all that black or orange everywhere. I really don't like the orange color. And then I'll just apply it to all the areas that we need to seal up. And there's a lot of ways of doing this. Like, there's a factory way of a certain bead width and height that the service manual recommends. I'm not that particular on it. I just make sure that I sort of have it rises up a little bit and it's totally covered. Some other engines have, like, some of the aluminum pieces don't necessarily align perfectly, so you need a lot more silicone in certain places. This engine's quite, this engine is machined really flat and all the parts really align well, so I haven't had that to be an issue. So just spread the silicone around, wipe the extra off. Now the tricky part, which is the rear main seal, we've got to get around. So this is what holds the oil in from coming out from the crankshaft that spins in here. So you got to make sure that this doesn't fold in. At the same time, while I make sure that the timing chain is on the right side of all the guides. So there is a special tool for this that I don't have yet, but I'm able to get it by hand. So that's, okay, so the seal is installed. So now I just have to make sure the guides and the chain are in the right place. I need to be over there. These are some of the things, after you've been working on an engine for a while, you know, like the little tricks to get it to be super smooth. So I'm getting there. But if you look up here, the chain needs to be kind of straddling that little spike right there. So I gotta make sure that that's on the right side of that. Make sure the seal looks good. And then it goes on. And again, I'll make sure that the chain's all in the right sections of everything. So this one, there we go. So what I'm doing is I'm looking under and making sure the chain is in the guide properly and that everything's gonna work when it's all assembled properly, which it is now. Yeah, so this is a static guide, and this is the one where later when we put the tensioner in, it adjusts and it keeps the right amount of tension on the chain. So now that we've got this installed properly, we can actually let this hang on that little nub, and I can put the bolts in. So while I'm putting these bolts in, are there any questions here while I'm going through this? Or if you have any questions on the stream, put them into, I got a team behind me, so we'll introduce them in a minute. Should they put them in the chat or in the comments?
We've got a few, put them in the chat.
Put them in the chat? Yeah, so if you have questions, put them in the chat. Jen, who I'll introduce you to in a few minutes, is gonna kind of sort through them, and then she'll pick some, and I'll answer them live on the stream right now, or in a few minutes. All right, so we've got all of these small little bolts. And are we on this camera? So we're gonna put all those in right now. You got that, Dylan? Yep. Yeah, cool. I'm ready. Yeah.
Right. Mikkel Block says, do you change it to port injection? If yes, will the direct injection part still be active, or will it be fully disabled?
So Mikkel Block asks if we're going to use the DI or port injection, or if we go to port injection, will the DI still be active? What we've been doing is we are not using any of the DI, which is the direct injection. And what the direct injection is the fuel system that injects the fuel directly into the combustion chamber. We are actually, it is a good system, a really good system, but with our aftermarket computer and the amount of fuel we need to make 1,000 horsepower on E85 fuel, it's well beyond what the factory fuel system was designed to deliver. So we've added 6 additional injectors into the intake manifold, and that's where we're going to run 100% of the fuel through initially. And then the direct injection, the injectors that go into the chamber, we planned on leaving them in, but we're probably going to remove them because you can run into some challenges by not using them, which we have been on the dyno a few days, and we'll show all of what those challenges can be in the video that comes out, in a couple of weeks when we show all the dyno footage.
Ruben Pozo asks, why did you replace just the one piston? Why is there one new piston?
Yep. So because this engine's been run and the pistons are not that impressive looking anymore, we wanted to show yesterday on the stream kind of what a new piston looks like and what all the trick looking coatings look like. So we decided to just replace one of them. And I also wanted to show the installation of the piston onto the rod, but I didn't want to do, you know, all 6 because of time. Yep.
And Jonathan Diaz
Yep.
asks, what sort of engine management will you be running? Are you using factory ECU and harness, or are you doing standalone with a custom harness?
Jonathan Diaz, thanks for the question. We're going to use total standalone. We're not going to use any of the Supra electronics from the car, and we're going to run the engine on an engine dyno. Because what we're trying to do is really prove out the mechanical side of the engine and try to make that 1,000 horsepower, or figure out what we need to change in the engine so it can support 1,000. We want to minimize the variables, and because the aftermarket's still really learning on how to make those kind of power levels with direct injection and by reprogramming the stock ECU, we didn't want to have those challenges and trying to work on the mechanical side as well. So we're working with AEM with their Infinity system, which we run on our other competition cars, and it's been really reliable, and they're in Southern California, so if we have questions we can reach out to them directly, and they've helped us out a lot. So I've almost got all of these timing bolts in, and then I'm going to come back and actually torque them all. And again, I've got the torque written down, which is, oh, you know what? So I would want to torque them all. You know that like feeling, like, did I forget something when I left the house? I've had that all week, and because we just have the tools that we have here, I don't have my 3/8 to 1/4 inch adapter, so I'm just going to do these by hand, which is fine on a cover. So these are torqued to 7 foot-pounds, and I've been building engines long enough to know what 7 feels like. So I'm fine with that. If it was something critical, like a rod bearing or something like that, or the head studs, you would always want to torque it. But for a timing cover with silicone, I'm totally fine by hand. And then I'll double check them like that. Okay, timing cover's on. So next we will turn it back over, and then we're going to go and put the pan on. And you'll see the chain sort of fall back out the top here. So bear with me, I'm gonna grab a pick, or I might just grab a needle nose, and make sure that the chain is all lined properly. This is one of those things, like, it's deep in the engine, and you gotta keep an eye on, because you can get into part of the build later and realize like the chain is caught up on something, and then you gotta take a bunch of stuff apart. So I'm gonna spend a little extra time now and make sure we don't have that problem. So what's happened in here is the chain kind of like wiggled its way to the other side of the guide. So now I'm trying to get it back onto the right side, which is totally doable, but one of those things where, so what happens is the guide floats a little bit. There we go. Am I sweating yet? So what I'm doing is, yeah, there's a guide and the chain goes in between it. And what's happened is the chain's kind of gotten out of that section, so I'm trying to get it back into the center of the guide. Sometimes it's the unglamorous part, but it's real problem solving with the screwdriver. All right, so I got that in there. Cool. Okay, so that's good. So now we can put the pan on. Okay, so I'm gonna get a fresh towel and a fresh glove because I broke that one. These are always kind of hard to get on with sweaty hands. Yeah. Oh, you're back. Nice. People were commenting. They're like, "Who's the girl in the front?" On like the chat. I was reading some of the chat comments from the video yesterday. Almost there. All right, so I've got my rags, towels hiding down here. Yeah. All right, so before I put silicone on, I'm gonna make sure that we're good. So this is good, oil pump, the chain, that's tight. Those are all tight. I'm happy with the chain guide. And I've got my oil pan hardware not here. So maybe it's down here. So I need to run to the back to where all the parts are and find the little baggie of hardware. So I'll be right back. Do you want to do a little toolbox tour? Why don't you go cruise through the toolbox? Dylan, you're welcome to open and close the drawers. I'll be right back. We'll keep going. Maybe, so I've got some boxes hiding under here. All right, so we can actually keep moving while maybe you just kind of, yeah, keep looking. So we're gonna skip the pan and we're gonna come back to it, and then we're gonna put the head on. So I've already pre-installed most of the studs because that's not that fun to watch, but I will install a couple of them. So I want to make sure this thing stays in the guide this time. So the head, we want to clean up all the oil again because we want the gasket to seal up real well. And we're going to use the OEM gasket, which we're not sure what the horsepower limit is on it yet. But we have upgraded all the hardware that holds the head down. It uses head bolts stock, and we've put head studs in. Yeah, and ARP made these custom studs for us for this B58 2020 Supra engine, and those are available. I don't know if they're available yet, but they'll be selling those soon. So again, just get everything all clean. And the dowel pins are already installed. So these two pins are what align the head so it stays perfect on the block. And there we go, so those are good. And then I've put a little bit of engine oil, just a little bit on the threads of the studs that go down into the block. So these just get installed by hand. You don't want to use like an impact or something. And then what you do is you kind of just go until they bottom out, and then out maybe like half a turn or a turn. And the socket is not that one. Oh, this is what I was using. So what I'll do is I'll just spin these in. Until it bottoms out, and then I'll just bring it out a little bit. The reason why you do that is you don't want that last thread where it tapers out to take a bunch of the pressure when you tighten it. So what's happening is when you loosen a little bit, and then when you finally put the nut on and tighten it, it'll be evenly load all of the threads in the block. And then once they're all in, kind of give it like a little just eyeball. Because what'll happen sometimes is you can get some little oil or whatever in there, and it'll start hydro-locking. You think it's tight, but it's not. And then just looking, making sure they're the same height, you know that they're installed properly. So those are all good. Our head gasket is down here. And again, this is just the OEM gasket, which is what they call a MLS gasket, or multi-layer steel. And it has layers of steel. And it comes factory with this orange sealant, and that helps to seal all of the fluids. And it only installs one way, which is this way. Again, it aligns on those two dowel pins. And then we're ready for the head. So here's the head. And what I want to do is I'm going to flip it over. There's no parts in it. All the Valvetrain is laying out on the table, and I've got some in the box down here. Once we get some more room, I'll bring out the rest of the Valvetrain. So I'm going to flip it over, make sure it's, again, super clean, and then we can start installing the head. So the head has been modified to where we've ported we've opened up the ports a bit to allow some more flow, and then we run Supra Tech brand valves, springs, retainers, and keepers. So the valves can deal with the really high temperature, and the springs are more pressure, because when you have a lot of turbo boost and more RPM, you typically need more spring pressure to make sure the valve closes and doesn't float at high RPM. So again, just clean it all up.
Paul's going to help you look under the table.
Cool. Thanks, Paul. Hey, Paul.
It's been a long time.
Yeah. So they look almost like this. They're going to have the head, and there's going to be a bunch of them. So that's nice and clean. We will then, let's see here. I'm going to clean up my space a little bit before we do this next big step. Unless, yeah, so you know what's weird is I had them out yesterday, and then I put them away, probably somewhere safe. You know when you put something safe and then you can't find them later?
I'll keep looking at it.
Thanks. You guys look through all the stuff in the back.
Large quantity, right?
All right. So, because it's kind of hard to get to these threads, once the head's installed, I'm actually going to pre-lube all of the threads and then put the head on, then put the washers on. And this is a special ARP insulation lube. So this lubricant goes on the threads, and because it's such a high torque, 135 foot-pounds, typically you need special lubricant for that. And then it comes with a brush, but I like this smaller brush. Just try not to make too much of a mess. So some of the challenges you can have with the really high horsepower turbocharged engines is making sure that you have keep the head gasket intact. When you have a lot of turbo boost, what'll happen is you want a lot of cylinder pressure, and that's the force that pushes the piston down. That's where you get the torque from, and that's eventually where you get essentially with the horsepower. But one of the things, you know, that's it's a challenge to keep all together is the head gasket, because as all that force is pushing down the piston, it's also trying to push up at the head, it's trying to push out through the gasket. And one of the reasons we upgrade these studs is we want to make sure to keep the clamp load on there and it not sort of move up and be able to blow it out. But what can also happen is with really high temperatures and really high pressures, you can just reach the limit of some of the materials and you can still blow the head gasket out. So we run these really trick ones on our 4-cylinder engines where it's a special copper alloy ring and a really soft copper gasket, and we have to do all this machine work to the block to make it all fit and work. And you don't want to have to do all of that crazy stuff if you don't have to. So we're hoping we can get away with the factory head gasket and just upgrading the studs to make the 1,000 horsepower. So we'll see how that goes. I know guys are already making at least 600 or 700 with unmodified engines, which is pretty good. But the difference between even 800 horsepower and 1,000 is there's a lot more a lot more forces going on there. It always feels a bit exponential as you try to make more power. Going from 300 to 600 is doubling it, but the next double is a lot harder to go from 600 to 1200. Okay, so I got all those all set up. Okay, so now I need help from, can you help me again? Yep. Okay, so this is gonna happen. I'm gonna set the head down, and I'm not gonna go all the way. What's gonna happen is gonna try to get hung up on this. Yep. Just put your finger in, get it out of the way. I'm gonna get the head past there a little bit, and then pull your finger out so I don't smash your finger. Okay. Ready? Gotta make sure I have a good handle on it. All right. Yeah, so just your index finger. Okay, wait, no. Pull the whole thing towards you a little bit. Just, yep, there you go. Okay, you good? Yeah, done. And then it needs to go down on the dowel. Cool. So the head's on there. Now we're gonna put the washers. And the washers have a top and a bottom. I don't know if you can get this, but this is the top where the nut spins. And you want the nut to spin on the washer because they're both hardened and they can deal with that pressure. You don't want the washer to spin on the block. So there's knurls on the washer, and those go down towards the, sorry, not the block, but the head. These go down towards the head. They'll dig in, not allow the washer to spin, and the nut can spin on the washer. So I'll go install all the washers. So if you bring the camera in, you can see where the washers go on the stud, and the little pocket where everything gets installed. The light inside the convention center is actually pretty cool. Like, we kind of set up here, and then it wasn't so good, but the convention center or the Toyota booth here has like these spotlights all above, and the light guy has like a little controller so he can start pointing them. So we got him to point, you know, all the spotlights over to this area, and like this is the best lighting I've ever had assembling an engine. It's great. And it's actually really low dust. I don't know if it's because it's dry or whatever, but
Someone was saying
nothing's been,
everybody else has to use a clean room when you're out here.
it's not dusty. Nothing's really been collecting dust.
Is this with a seal on it or no?
Mm-mm.
It's just a standard one?
That's weird. So now I'm just going to get assembly lube on the top of the washer where the nut meets it. I know. Where's Jen? I think we look for the trash can where we dumped a bunch of the wrappings and stuff from this morning. Yeah, maybe look through there. No, there's even more stuff than that somewhere. I had a couple friends text me last night after the first show. They're like, dude, how are you doing that live? I don't know, man. I'm just doing what I normally do, I guess. But it's like having a friend over, you know? It's kind of fun to work. I remember working in my garage or in my shop. And I actually, when I was like 16 years old, 17 years old, I used to go to the local tuning shop. And I was the kid that would just hang out and watch the guys work. And I just want to sort of like absorb the knowledge there. And a lot of the older guys don't want to like teach you. They don't want to take the time because they're trying to work, right? But sometimes if you just watch their their habits and their patterns, it can rub off, and hopefully they're good habits. All right, so next is the head stud. And it's 9/16. And we're going to use an extension. All right, so now we've got to put the nuts on the studs. And what I'm going to do, like all the rest of the stuff, is I'm just going to get them started. And then I'm going to zap them. And then torque them down. So certain engines like this that are all metric, and then when you modify them with sometimes performance parts or traditional studs like this, they actually have a metric thread that goes into the block, and then a standard thread on the top of it, on the top of the stud. So where most of the stuff is metric, this is actually a 9/16 standard 12-point nut. So you still have to have a lot of different sockets and tools. You never know what you're going to need. And I was always used to the engines we worked on used like 10 millimeter, 12 millimeter, 14 millimeter, 17, 19. But this engine uses a lot of 13s and 15s and sockets we don't use, that we rarely use. Oh. No problem. Okay, so now that I've got all the threads started, I'm actually going to zip them all in so I don't have to spend a bunch of time with that. And I'm going to do that with the impact. And the head studs get tightened in a sequence. So from the inside to the outside. So I'm going middle, then the next out, and then the next out, and then all the way to the outside. And the reason you do that is so you evenly add pressure to the cylinder head and the whole block, and you don't crack anything. All right, and the torque wrench we're going to use on this, because it's 135 foot-pounds, is a big 1/2-inch drive. And if I wasn't breaking a sweat earlier, I'm going to break a sweat now. And we're going to do it in a few stages. So the stages are written down on my piece of paper here. Head bolts, we're gonna go 50, 90, 135. So, so I will double check everything is seated. Looks fine. Okay. Actually, before I do that, I just want to get everything compressed nicely by hand. To like 20 foot-pounds. Make sure everything feels fine. And then, now we'll do 50. I'll go to the NHRA drag races sometimes, and they have those guys that, you know, they rebuild the engines basically between every run. And they have like the left cylinder head guy and then the right cylinder head guy, and there's this guy underneath doing the pistons and rods and all that stuff. And they always kind of seem like they have the bigger guys doing the cylinder heads, because I think those are torqued like over 150 foot-pounds, and they just jam the things on with the impact, and they come back with the torque wrench, and they're just like, looks like a workout every time they run the car. But those guys with the top fuels and the dragsters, they know how to keep the head gaskets on. And they typically run, at least what I've seen in the past, is they run like a ring that stands proud in the block or the head, and then a soft copper gasket, and then a receiver groove like on the head. So what happens is that ring pushes the gasket up and into that receiving groove into the head, and that's how they're able to keep it together and make the crazy power that they do. All right, so I'm just gonna double check that I got 50 everywhere. This is not in sequence because I'm just checking, but yeah. Okay, so now we're gonna go to 90. Okay, so I might not talk for a minute just so I don't skip anything. Socket fell off. I thought I brought my magnet. It's okay. I got these. 6. All right, so this is 90 foot-pounds. All right, so now we're gonna do 135. Okay, so I'm gonna go back now and double check them all.
I want to introduce you to Sam. You've met Sam before from Hard Throttle.
Hi,
Hi.
good to see you.
Sam, come over here. Check out your fingernails.
Oh, sweet.
Hold your hand there for a second, man.
What'd you say?
Hold your hand there.
Okay, I got
That
it.
is a brand new Supra on her nails.
I have it hand done in New York City.
I really like it. Those are nice.
Yeah.
Did you bring up a picture and then
Yeah.
she copped it?
Hand draw everything, so.
Nice. Good job.
Yeah. He needed a break.
All right, here we go. So everything's torqued, but I'm gonna go back and double check it. Normally I do everything in the sequence, but if I'm gonna double check, I like to do it in a sequence that I don't skip anything. So I'm just go from left to right and left to right. And they should all just click because it's at maximum. Something turns more, then I missed the torque. And it's a good thing that I double checked. If we keep getting this, that means we're good to go. And I didn't miss anything, so done. Okay, the head's bolted on. All right. And then always try to turn the torque wrench back to 0. Because when you leave the spring compressed like that, it can sometimes lose some of its springiness, and then your torque wrench can lose its calibration. And then we're done with the big one, so I'll put it back in its box. All right. Next, we're going to work on the Valvetrain, which we can do without the oil pan that we still haven't found the bolts yet for. No. Let me take a break. Why don't we take some more questions? So if you guys have any questions on the stream, put them into the chat. Jen will figure it out, a couple to ask me, so go ahead and put those up. If you've asked something and you're still online and we didn't get to it yet, go ahead and post it again. Do you want to do like an intro with you guys?
Yeah, whatever. I've got a few questions for you.
Let me know when Dylan's on. Hold on, I'm a little sweaty, so I'm gonna get a new towel. And is my hair okay?
Yeah.
Okay, thanks.
Perfect.
Sorry. It's dry in Vegas, and sometimes it makes me. Okay.
All right. So Levi,
Uh-huh.
aka Emiata, do you foresee this engine being prevalent in motorsports, in pro mod, import drag, FD level drifting at high horsepower numbers in 5 to 10 years?
Sure. Levi, thanks for the question. I think the engine has a lot of potential. I think the aftermarket and us are still figuring out how to make a bunch of power out of it. I think in 5 to 10 years, I think it does have a good future. There's a couple things that it has going for it. Number one is I think there's a good ability to make power. And number two, variants of this engine are in a bunch of different cars. So the ability to sort of swap different B58 parts or to find like not super expensive brand new cores, maybe there might be a lot of ability to do that in the future.
Really no way.
Really no way, okay.
How long does it normally take to put the engine together?
How long does it normally take to put the engine together? So, Matt, I've put this engine together once, and I did it on film. You know, I've filmed myself doing it, and that typically takes 4 times longer to do something when I film it. I think I can knock one of these out in probably 4 hours, maybe. We're trying to do it in 6 hours here at the show, which I think is totally doable. But I think about 4 hours, and maybe even quicker once I get a little bit more, used to it, and then have all the tools and parts laid out, ready to go.
Husing29 has a question. Are you using more or fewer aftermarket parts on this engine versus a 2J?
Yeah, Houston
Yeah.
29, thank you. Are we using more or less than a 2J build? Depends on the 2J build. So this one we're not using very much. It's pistons, rods, head studs, valve springs, retainers, keepers, definitely the turbo manifolds, things like that. But maybe similar to what you do in like a 2JZ build. Yeah. So, any questions from you guys?
What's with the
Yep. So the pilot bearing boss, he's asking about, like, we have this extra feature that we weld onto the crankshaft. So the deal is these engines come with a torque converter on them, and they don't have a pilot bearing due to that. And the way that the engine dyno is, it needs a pilot bearing to align everything. And later on, when we put a manual transmission for, you know, if we ever do this, use this in maybe like something with a manual transmission, we need that pilot bearing. But we need a pilot bearing for the engine dyno. And we've found that if we press something in, it almost always fails. And we've had them welded into other cars that have lasted forever. So we found that you can weld on the crankshaft in a non-critical area and there not being any issue with it. So that's what we did on this. Yeah. All right, so I'm gonna get some gloves back on.
I know what you drive.
Come on in. I couldn't find your bolts.
Yep. Yeah.
But I found ARP.
Found the bolt guy.
So maybe you guys can talk about what's missing and see if maybe it's somewhere at the show.
Oh, sure.
How you doing?
Thanks for
Chris?
coming by.
Good.
Yeah, thanks for, we worked with Jay, and he turned around some custom studs for us really
Okay.
quickly. That was great. I think the bolt-wise for the oil pan, they're,
8mm 125.
I think they're 8mm 1.5.
They might be 1.5.
Yeah, they're 8mm 1.5.
Okay. So do you have a
We-
sample of that? Or just how much you need? So you just need a.
Oh, they're,
Yeah. So. Okay.
but shorter than this.
Okay.
So,
you want them down like a 16mm or 12mm long, real short. You want like that much out?
no, probably 20 mil.
Okay.
20,
Okay, we
25
can do
mil is
that.
fine.
Okay.
And if not, it's not a huge thing. We can wait for the pan till tomorrow and we'll look at for more for the bolts. But if you've got something, we'll use them.
Okay.
Yeah.
How many pieces you need of that?
We need
I can count those as well.
all of
Okay.
those.
Okay. And I'll get something and bring it back to you in a few minutes. But we did bring a bulb in with us, so we have it in the show booth.
That'd be amazing. All right, we'll
Okay,
be here.
thanks,
Thanks,
man.
man.
Can I take one sample for a second?
Yep. Yep.
Okay, we'll be back.
Okay. All right. See you in a bit. Oh, actually, let me give you,
Different sample.
because I might use those right now.
I'll bring you back what I got.
Go ahead and bring one. If you can come back in 10 minutes, that'd be great.
Couple
Yeah, no problem. Okay. So what just happened here is Jen found somebody at the ARP booth, and they have a bolt bin, and they're gonna see if they've got their bolts that would already be the right size that we can just use in the oil pan. That'd be amazing, because, you know, who'd think you could just find bolts? I guess this is the place where people build bolts, right? Well, not build bolts, but sell them. Okay, so what have we done? We've got the head on, it's all torqued on. In addition to the main head studs, there's a couple of smaller bolts, and these help seal up the oil, the head gasket up in the corner here. So if you can look in here, there's a couple of areas where you can see these bolts go. And we just put them in and then torque them. And I'm calling these the head to timing cover bolts. And the head to timing cover bolts are 14 foot-pounds. So I'll just go up to 14, done. And the reason I'm putting these in is so I can finish this part. And then we can start putting in the cams and the valve train. And the cool thing is with the oil pan, I just need a couple of bolts to kind of hold it on. I may not even put the silicone on it if we don't have all the bolts. And then I can put it the rest of the way on either tomorrow or or back at the shop or something.
It's like supposedly top secret. Or not like that. It's just that they don't want to go in the information. So might not.
So done, 14. Okay. I'm gonna clean up a little bit more now. So we're done with the ARP lube because that's all installed. And we're finished with the 9/16ths. 12 point. And this. Okay. Next is, so this timing cover, the timing chain. There's a bolt that goes on the side here, and it keeps the timing chain guide all aligned. And because the threads are the only thing, come around over here, I'll show you what I'm gonna do. The timing chain guide rides on this pin, and we need to put a little bit of silicone on the threads here to keep the oil from leaking out. So, it's a little bit there. And I'll get a Torx for that, which I think is this one. Sometimes your hand's all slippery, it's hard to get the sockets off. So I just use a little screwdriver, get it off. Let's see here. I really like these ratchets. It's like a 1/4 inch ratchet and it's a flex head, but it's got a 3/8 drive on it. So when you want to install stuff sort of quickly, I feel like I can use it more effectively or more efficiently, and then I don't over torque it like you might with a big ratchet. So that goes through the head and it aligns the guide. Just like that. And then that gets torqued to T30 bolt into external block 6. No. Oops. Low. Just 8 foot-pounds. And then I'm gonna get a rag and clean up the extra silicone that came out of there. Okay. Timing chain timing guide looks good. That looks good. The next step is to put the cams in. In order to put the cams in, we need to make sure everything's at top dead center. With this engine, to get it to top dead center, we actually need to put the flex plate on. What I'd like to do, let's see here.
That is great. You can't do that. You guys are awesome.
So
Okay,
there's an elevator?
it looks like something's probably gonna happen here. So I'm gonna flip the engine over. Yeah, you know what? If we can get away with just a couple of bolts,
Okay.
then I can put the pan on, at least temporarily for the show. And then when we get back to the shop, I can finish it. So I'm gonna go ahead and flip the engine over, and then I'll set the pan on there. All right, so the pan. Dude, look what I found, the pan bolts.
That's good.
You know how like you put something, I'm gonna put it somewhere safe so they don't get lost? They're taped to the oil pan. It's the safest place. If only I knew.
We all been through there, bro.
Thank you guys. I think you were the catalyst in us finding them, but let's see, look, you know what? Let's compare it, and then you guys can do some R&D right now, and then you'll know. We got a B58 oil pan bolt already. Let me lay these out here on my towel. Classic. All right.
Okay. Well, here's the bolt you loaned us,
Yep.
and there's a 20 mil sample replacement.
Ooh, I like yours.
Yeah. Well,
Are those stainless or nickel
these
or?
are high-strength stainless, custom 450 material, made in USA, and we cold reduce it. It's 170,000 psi, which is 20% stronger than grade 8.
Let's use them.
You're welcome to.
Yeah. Let me lay these out and see how many we need. If you guys want to hang out for a minute,
Okay.
I'll make a little bit of room here to do that. And then we'll put on our upgraded oil pan bolts. All right, so we've got 2 long ones, which I don't know if you've got real long ones like this. It takes a couple of these.
Okay.
But if you got 2 of those, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, it seems, plus the 2 long ones.
1 or 3?
Pardon me?
1 long?
2 long and then 21 short. So let me do this. Let me start putting silicone on this while the guys over here set up all of our hardware. This pan doesn't use any kind of dowel pins, so we just put something flat on the edge and we align the pan with the back of the block. But we'll get to that in a minute. So I'm gonna, same thing, light the timing cover, put a nice bead of silicone. Dude, I can't believe you guys brought over a whole bolt pin. That's awesome. How do I come up on one of those whole things?
Probably make some arrangement with that. Here's some washers if you want to use them. If you don't.
Okay. Wow, cool. These are nice.
Here's those, and here is your stuff.
Amazing. So I'm just going to spread around the silicone and make sure it's everywhere. So in a situation like this block where everything's flat and everything is the same level, I'm not so worried about a big tall bead, but some older engines you may not want to be so easygoing with the silicone. You may want to have a lot thicker bead, but I'm confident on this one that this is just fine. So once we got that all spread around, and I'm confident we've got that good, then I'm gonna put a little extra silicone where these gaps are. And everything else is super flat. Okay. And then we take the pan. Let me try not to drop it on the carpet. I like to just take like a mental picture before I put stuff together and just remember back to remembering that I tightened everything and whatnot. Okay, so next we're ready for the bolts. So the two long ones go up here. No problem. And these are a 12 point metric.
10 millimeter?
Yeah. In stock. So 10 millimeter 12 point socket. So what I'm going to do is I'm going to get a couple of corners. We're going to go no washer because I like less parts. And this engine, the oil pan doesn't go down on any sort of dowels or anything, so it actually can move around a little bit. What needs to happen is it gets lined up on the surface here. Just like that. Boom. Okay. So now we can put the rest of the hardware in. 1, 2. Do you have, let me see here. Oh, that's the right size. Oh, that's the starter bolt. Okay. Not every hole gets used because the starter also bolts up to this area. Now I'm starting to think what else we could swap in this thing, right?
Well, we're only in 23,313, so if you think you're good, we'll...
Yeah, let me get all of the... Let me just get them all started.
No worries.
And you guys are welcome, if you got camera or anything, you guys are welcome to share or take pictures of this or whatever on your stuff. So back in the days, the engines we used to build had gaskets on all this stuff. Gaskets between the oil pan and the block, gaskets between the timing cover, like all these things. And I remember that they started changing the engines over to just use silicone. And at first I was thinking it was just way worse. Like, I need a gasket or I got to clean all the silicone off. But nowadays I believe that the silicone with the machine surface is definitely better than the gasket. I do like O-ring setups, but typically you only see O-ring setups on like full-on race builds. Okay, so we've got all of the hardware we need, so we're good. Can I hold on to the washers? And cool.
Hey,
thank you very much.
thanks a lot.
I appreciate it. Thanks, guys.
If you need
Thanks,
something
dude.
else, we probably got it.
Okay, thank you. Yeah. Okay, so now I'm going to finish tightening these and torquing them before we take another break. So I'm going to zip them all on real quick. Bling bling. And then I'm just going to torque these to 15. Sure, you could torque them more, but it's just an oil pan bolt, so I'm not going to get too crazy with it. And I'm going to go in a little bit of a pattern here, kind of from the inside out. And then I'm going to go double check them by just going around in a circle. And I'm going to stop in a couple minutes and we'll answer some more questions. So if you guys, if you're just joining us, we're at the 2019 Sema show. We're building the 2020 Supra engine. This one's been modified. We're trying to make 1,000 horsepower with it. We've changed the pistons, rods, head bolts, valve springs, retainers, and then put a much larger turbocharger, different intake manifold, a bunch of other stuff that we'll get to tomorrow. We're doing the live build today. And then we're finishing it up tomorrow, which is Friday, from 1:30 to 3:30 Pacific time. So we will continue tomorrow. Right now we're trying to get to the cylinder head, the Valvetrain on the cylinder head. So we've already installed the head, and now we're doing the oil pan. And then once we get through that, we'll work on all the Valvetrain. So the cams and the rocker arms and timing chain, all that kind of good stuff. So if you got any questions, go ahead and post it on the chat. And then Jen will go through them, ask me, and then I'll answer the question. Cool. Oil pan installed. All right, so Jen, can we do, is there any questions here? Oh, what's up, man? Good to see you.
Good to see you.
Yeah, all right.
This is great, dude.
Oh, thanks.
This is amazing.
Yeah, it's been fun.
I talked to Scott when he's like, yeah, I just dropped off some stuff for Steph. Snap-on Scott.
Yeah.
And he's like, you should go check it out.
This box I've been wanting for a while. Like, the thing is, I like the big boxes, but in order to get into our engine room, I can't get it around so much. So this is perfect. And it's just kind of engine building tools, so I don't need, the giant one. Yeah, it's great. Any questions here? You guys good?
Was there any issue, because I know B58 stock have that electric arc wire spray coating on the cylinder walls. Is there any issues with rebuilding because of that?
So the question is there any issues with the plasma sprayed, I think? So some of the technology on the block is an all aluminum block, and they plasma spray a steel, for lack of a better word, like a liner on the cylinder walls, and that's what the piston rings ride on. It's very thin, so you can't really overbore it because you'll go past that coating. So we've decided to not touch it at all. We're leaving it in its OEM condition with the honing and everything, and then we're using the OEM rings, which are matched to that, and then we designed the JE pistons with them to work with the factory rings. And in the future, if you need to, I guess, rebuild it, one option is to just replace the block, which may be, for us, it may be actually less expensive to replace the block than to deal with sleeving it, machining it, and doing all of those post processes. Or potentially someone could go in there, bore it over, and put a sleeve in there. So, I don't know what the future setup will be, but for now, we're trying to make this factory stuff work. And because it's a closed deck block, we think we're hoping that it's strong enough to make the power that we want.
Thank you.
Good question.
Matt Williams wants to know if the drivetrain will handle the 1,000 horsepower, or do you think that's going to need some modification as well?
Yeah, so Matt Williams has a question. Thanks for the question. Will the factory drivetrain deal with the 1,000 horsepower? It's a good question. So for us right now, we're trying to make the 1,000 horsepower. We're actually going to be dynoing it on an engine dyno. So without the whole car, that way we can take that variable out of it. There's it can be challenging to get the factory computer and electronics and all of those systems to be able to get to triple the factory horsepower. So we're trying to take them out of the equation. Once we get to our horsepower goal, if we are implementing that back into the car, then we address that stuff. Right now, I mean, it's a challenge. People are still working it out. I think 6 months or a year from now, not a problem. I guess the real question is, can the factory transmission hold it? I don't know. I think guys are already running, for sure, low 10-second quarter miles with slick tires. And I think I've heard some Puerto Rican guys have already run in the 9s. So if that's the case, then that means the transmission is pretty robust. But honestly, transmissions are not my specialty. So I can't answer that question very, very well.
It's a ZF
Yeah.
Trans, right?
Yeah, so I think they use the ZF Trans, which is in a bunch of different cars and are known to be pretty robust. But my experience with, I don't have any experience with the ZF, but my understanding is they're actually really strong. Yeah.
Rick M wants to know, how would this engine perform on the street, and could it be used in a daily driver? With regular driving, how long would a motor like this theoretically last?
Yeah. So Rick M wants to know, will an engine like this, kind of how would it perform in a street car? And it should perform similar to stock. It might make a little bit more, noise because the forged pistons have a little bit more piston to wall gap, so they can deal with the really high temperatures. But other than that, it should drive very similar. And the setup that we're doing now for the engine is not necessarily race only, and the products that are being designed, like the pistons and rods and things like that, would totally work on the street.
Big Brap wants to know, what are some components that you feel you want to continue to develop and engineer in the future that might be weak points?
Yep, so Big Brap wants to know, what are the components that we may want to continue to develop? One could be the head gasket, some of the sealing there. Another is the crankshaft. We'd like to potentially build a stroker crank so we can get more displacement, maybe make it a 3.2, 3.3, or even larger displacement. So that would happen with a custom crankshaft. And then we'd also like to run larger lift camshafts. In a race application, we don't have to worry so much about smog. So we can run a bigger, more aggressive camshaft, which will allow the valves to open more airflow through the engine, and then potentially make more power at lower boost and even make more power at higher RPM. All right, so I'm going to put my gloves back on, another set of gloves, and then we will keep going.
Got about half an hour left.
Okay. The engine's getting heavier as we get more stuff on it. All right. So the next step, we're going to put all the rocker arms in. So I'm going to clean up, make some room, and we'll get to that. So give me a minute while I clean up.
Stefan, have you seen any limits or any effect on host with the exhaust ports being internal like that?
Yeah, so the question is, having a two exhaust ports and the integrated exhaust manifold, have we seen much of a limitation there? We haven't gotten to the power yet where that might be an issue. I don't know yet. We don't know. Intuitively, like in the past, we've seen when you have a 6-port head and you go to like an equal length header, they will tend to make more power. And this is just inherently, unequal length. We're hoping that the factory knows something that we don't. And maybe there's some stuff around it. But that might be something, once you get into the 4-figure range of horsepower, to where we might reach some limitations there. And then that's kind of part of the process where we try to figure out ways around it. I don't know if it's porting it more or something else, so we can continue to make more power beyond that. But that is something that, we're looking at that might be a limiter for some of the really high horsepower.
In races of the V58 had
Right.
I don't know how much different they are really.
Yeah, so he's asking what, you know, maybe there's some options of swapping some other B58 parts. I think that's totally doable. We want to build this engine with all of the 2020 Supra components. So that's the goal here. But I mean, that's always been a thing with engines. You kind of look around and you see, all right, what other cars use a similar engine, and what other different components are they using on that engine that we might be able to swap over to the build that we have here. All right, almost cleaned up. All right, so the part I'm going to bring out now are all of the rocker arms. So these are the intake lifters and rockers. And the way that these are set up is the cam pushes on these rocker arms. The rocker arm then pushes on the valve, and that's what opens the valve. And engines of the past, they may need valve adjustments. And with the newer engines, they tend to run the hydraulic lifters. Actually, a lot of older engines use hydraulic lifters too. And they don't need a valve adjustments. They're self-adjusting. The intake, in addition to having the standard rocker arm, has an intermediate rocker arm, which are these. And we'll get to how those install in a minute. But it's been even a lesson for me on how this modern type of valve train works. All right, so we're gonna start by putting all of the intake rocker arms in. And so what happens is the rocker arm pivots on this hydraulic lifter. The cam, or the intermediate rocker, pushes on the roller here, and then it pushes down on the valve. What we have here is a valve, the titanium retainer, the custom SuperTech valve spring, and then the valve is what's holding it all together. So that's the tip of the valve up at the top here that you can see. And these are some of the components. Pardon me?
What do they use on this engine to set TDC?
The flex plate. So that question is, how do we set TDC on this engine? And you actually use the flex plate. So in a couple minutes, I'm going to install the flex plate, or the flywheel. And there's a pin that we're going to install through the oil pan, and it locks it into top dead center. So a lot of little parts in this engine. Whoa, slippery, but I caught it. Oh, you know what I need is the one extra bolt that the ARP guy borrowed to look at, that he brought back, that I need to put in. There's probably the one person watching the stream that's like, dude, he never put that bolt in that the ARP guy borrowed. Here it is. So we'll put that one in. Done. Okay. So that's good. I'm gonna leave this out because I'm gonna need that in a little bit. Okay, so now we're gonna set the engine to top dead center. And the way this is set up is it uses, so this is the end of the crankshaft, and this is where the flywheel or the flex plate bolts up to. If you're looking at this feature, this is a pilot bearing that we installed for the engine dyno, and then we actually weld it onto the crankshaft. We've had really good luck with welding stuff actually to the end of the crankshaft for pilot bearings and such. We've had a lot of bad luck with trying to press things in. They always kind of work their way loose, and typically you wouldn't want to weld on your crankshaft, but we haven't found that to be an issue. So we continue to be confident doing it. This is the pickup wheel. So inside of here there's little magnets, and there's a sensor that will slide in here later, and that's how the engine control system knows the position of the crankshaft. And that gets installed back here on the flywheel end. A lot of other engines will install some of these pickups on the front, but having the pickups for the crank angle and the timing chain and all that stuff on the back of the engine can reduce a lot of harmonics, because when the engine is firing, that crankshaft can wrap up and sort of twist a little bit, and the twist and most of that flex is happening eventually at the nose of it, not necessarily so much at the flywheel end. So if you keep these components on the flywheel end, you will introduce less harmonics into the timing chain and the valve train. So it's a good thing. Even though there's been a lot of comments that it's harder to work on, which may be true, but when you're dealing with a performance engine, sometimes you sacrifice some ease of working on the car for performance. So I'm fine with that. So I'm just going to put a couple of bolts in here for now. And that only goes on one way. The flex plate only goes on one way. It has a dowel, and so it only goes on one way. If you come around over here, I'll show you how we set it on top dead center. So I've got a whole drawer of special tools here. We take this pin, which if you ever put it into the engine, you got to make sure that you don't start the engine with this in, because it'll rip a bunch of stuff out. So it goes in through a hole in the pan. Can you see that?
Yeah.
And then the other side of it, it slides into the flex plate. So I can turn the engine, boom. And then that's it. It's locked in the top dead center. There aren't any timing marks on the pulley end, because as far as like service goes and you don't check this thing with timing lights and stuff. It just either works or it does. There's nothing to adjust. So, but for us, we do need to link it and set everything up with the AEM Infinity ECU. So we've locked it in at 0, and on the other end, I've actually put a 0 timing mark on it. So I don't have to, so we can have it running and see where top dead center is. So we got it now on top dead center, and we can start installing the rest of the cam stuff. Got another bag here of exhaust lifters and rockers. So I can install all those. The intake and exhaust lifters and rockers are actually identical. And the modern engines I've worked on all use this type of roller rocker. So instead of a pad, they have an actual roller and a needle bearing inside there, and it's lower friction and longer wearing than an actual cam shaft pushing on a pad. Jen, how are we doing time-wise?
15 minutes.
So 15 minutes, okay. So 15 more minutes, I'm gonna try to get, I'll try to get the cams in 15 minutes. So we will start with the intake side. So the intake side's over here. I'm gonna put a little bit of engine oil on all the bearing races. Oh, these don't need it actually, because of the third cam. Okay, so what's interesting about this Valvetrain is it actually takes 3 cams, you can call it, but this cam is what adjusts the variable valve lift. So this goes in first, and then the cam caps go on it, and they're all numbered, and they have to go back in their same locations, and they can't be swapped head to head, because when they line bore all of these, there's slight differences in all the machinery, and because the tolerances are so tight, everything is just matched. So they number them from the factory. So you gotta make sure that you put them right back where they came from. All right. And then I will use the impact to put them in, and I'll come back and torque them. So I'm just using the impact like just a little bit so it turns and doesn't put any kind of like torque on it. So it just stops right when the bolt head bottoms out. And then if I put a bolt in, I torque it. So I don't want to forget anything. I'll actually torque it right now. So all of those cam caps get torqued to 7 foot-pounds. So we'll go and torque all of those that are already installed. All right, so next we're going to put in the intake cam. So the cam actually rides on these bearing races. So I'm gonna put a little bit of engine oil on all of them. And then the intake cam is this one. And now we'll put the cam caps on. In my head, as I'm doing this, I'm kind of looking at other places, making sure I didn't forget anything. Because everything has a kind of a sequential order of assembly. And if you forget to do something deep down, you might have to pull it all apart again to put that component in. Cool, and then I'll start these by hand just to get the thread started. And then again, I'll zip them in and then come back and torque them. Back in the days, I used to use a lot of air tools and always had that kind of air cord, but nowadays the electric stuff's so good. Like, I don't remember the last time we brought out an actual air impact or something like that. All right, same thing. These all get torqued to 7. And I'm not so worried about the sequence on these. So I'll just go from left to right. That way, I am sure I didn't forget any bolts. So this has been a really fun project because it's going into this world of sort of the unknown. And that's always a bit scary, but I've learned a lot from this project and learned a lot from what, you know, the factories are doing nowadays for technology, and really appreciating a lot of that technology. Okay, so we've got a camshaft and we've got rocker arms, but the camshaft doesn't push the rocker arms yet because we need the intermediate rockers. So these are what the camshaft pushes on. It pushes on this, what they call intermediate rocker, then that rocker pushes on the main rocker arm in the bottom. And this is what adjusts the variable valve lift. So what I do is just set all of these intermediate rockers in there. You might actually get a good view on this side. So all these get set in between call it the third rocker and the third camshaft and the intake camshaft. Yeah, if you guys want, some of you guys want to come close and check it out. It's pretty interesting the way that the rocker arms are set up. So the camshaft pushes on this top rocker arm. Depending on where this third camshaft on the eccentric cam there is located, it changes the rocker ratio from like barely lifting it open to full lift. And there's a motor that switches this rocker ratio super quick, and a lot of the throttle is actually the rocker ratio and the intake valve lift changing versus the throttle body opening and closing. And it's crazy that they get all this stuff to go, you know, tons of miles, and it doesn't make any noise, and yeah, it just seems seems to work well. You don't even think about it. Okay, so now these are called the gates. So this is what keeps those intermediate rockers aligned, and they have two little grooves in it. And the intermediate rocker rides in that groove. And that's what keeps everything all aligned.
I think that's a wear item.
Man, I don't know, man. Nowadays with the materials and the way that they oil them, a lot of time they don't wear. I think wear items in engines is sort of like an old thing, yeah. Because I've pulled apart 20-year-old engines that have been run well, and the bearings, they look almost perfect. And you check out the tolerances, and they're within like tenths. So I think unless you if you maintain them well, then you're pretty good.
What material is that gate?
Dude, I don't know, man. I think it's a steel with some sort of coating on it. I would check if it's magnetic, but I think I forgot. I didn't bring my magnet. Okay. So we're probably just gonna get through this intake stuff here, and then we'll be done for the day. And then tomorrow we'll finish the Valvetrain, and then we also have the turbo manifold, the turbo, and the intake manifold all to install. This is a little bit different size.
How much of the hardware is torque to yield? Is it reusable? Or?
Like half of it. This one's not, but like the head studs are, the main studs, a lot of it is. The service manual says don't reuse them, although I've had fine luck in the past reusing certain things, but I guess you are taking a bit of a gamble if you do that. So these are set up in a way that they need to be pushed up and across. There's a certain installation procedure. So I'm actually going to use a click torque wrench on this. So these are 15 foot-pounds. And that torque wrench is here. And then I've got a special tool that I brought. There's actually a special service tool that holds this thing up. I'm going to use these Nipix pliers. And so this needs to be pushed up against the pad and seated. So what I'll do is hold it up and seated. This is definitely a bit of the rig way to do it, but it works just fine. That goes there, and then we get a plastic hammer. All right. So I'm going to torque this one, and then we'll sign off in a minute. Done. So I'll do that 6 more times, and then now everything is captured. After that, there's a secondary spring that goes in, and then we'll get to all that tomorrow. So thanks everybody for coming by and watching. I know some of you guys were here pretty much the whole time, or if you're just stopping in right now, thanks for coming by. Again, we're at the 2019 Sema show, and we're doing the live 2020 Supra engine build. If you want to see more of this, or if you want to get caught up, go to the Papadakis Racing YouTube page. You'll see some of the other videos where we tore it down, the parts that and why we modified certain parts in the engine, and then the first time we assembled this at the shop. If you're interested in seeing this on the engine dyno and us attempting to make 1,000 horsepower, hopefully we hit that number, that's a video that's going to be released very soon. So go ahead and subscribe to the YouTube channel, the Papadakis Racing YouTube channel. If you watched this video, the live one, and you liked it, please hit the like button. And we'll be back again tomorrow, Friday, finishing this engine from 1:30 to 3:30 Pacific time. Thanks for watching. Okay. All right. Thanks, guys.